Hello everyone. In this video, I will be showing you how to plot UV spectrum from the raw data files which are obtained while recording the UV visible spectra. So in front of the screen, there are three sets of data that we are having for which we have to plot the UV visible spectrum. So in order to plot the data, we will use Origin, which is the most popular data analytics and graphing software used by the scientific community everywhere around the world. So once we open the origin worksheet, we will get back to our data set and assess it with the notepad, copy the data that is available, and paste it in the appropriate columns. So on the x-axis, we have the wavelength. The unit will be in nanometer. On the y-axis, we have the absorbance, and since the sample name, we check again. The sample name is TCPP. So in the comment here, I will write TCPP so that the sample name is indicated in the spectral plot. So now you can either plot the data directly to obtain the UV spectrum for this particular compound, or you can wait and add the other data sets and obtain a overlaid spectra for all the combined compounds combined together. Now let us go to the other compounds. For the time being, we will ignore uh, enhancing the spectra in any manner. So let us go to the other compounds that are there. So the other compound here is E3IA. So anyways, let us open the notepad file again. So we'll copy the dataset and we'll insert the dataset here. We'll just make sure that the entire dataset has been copied. However, you can see that it has not been copied properly actually. There is certain problem here. Okay, so let us try and identify what is the issue. Okay, so uh, okay, so the TCPP dataset follows an increment of zero point 0.5 nanometer, and the dataset for E3IA follows an increment of 1 nanometer. Now that is a problem, and considering that that there are 800 data points, it will be extremely difficult for us to remove any of the data points from 800 data points manually actually. So what to do here? So in this particular case, we will again make use of an Excel sheet and use its functionality. So in order to do so, let us copy the dataset for TCPP. We will paste the dataset here, label it as we had labeled it in the origin file. Now on the C1 row, let us label it as a helper column. Now, what is the use of labeling a helper column? We will understand it uh, now. So, in the C2 column, we will use a formula which is equal to is EVEN and ROW is even row. Okay, so when you expand the formula across the entire data set, you see the alternate cells are selected as true and false. Okay, so is even row equal to is even row. It means it the formula is asking the Excel sheet to identify if that particular cell belongs to an even row. So since the cell is in second row, the answer comes out as true, and for the third row cell, the answer comes out as false. Now you can see all the zero point 0.5 increments here have been labeled as false. Now we can carry out our operation. So for that, let us go to the data tab and apply the filter function. In the filter function, we will deselect the true data set and click on OK. So all the odd columns will be selected. We'll select all the odd columns, delete it, and then restore the true columns. So all increments of zero point 0.5 in the data set has been removed. Let us copy the data set now. Let us delete whatever we had entered earlier and we'll enter the fresh data set. Okay. So next we go for the insertion of the next data set, which is E3IA. So select, copy, and then paste. Just to make sure that the data set has been entered correctly or nothing is missing out. Okay, fine. This is okay. So the name of the sample is E3IA. Absorbance in here. So there is a third data set that we need to deal with, which is C3IA. So let us open and see. Okay. So here too, as you can see, there are increments of zero point 0.5 between each between the data that has been recorded. So we have to remove that in this particular case because one of the data does not conform to that zero point 0.5 increment. So let us copy it, go to the Excel sheet that we created. We will hit Control Z. The false data is also there. Okay, true, false. Okay, every data set is there. So we will just paste our data set here. Happened. Okay, fine. C3IA. So we will paste our data set here. So once that is done, just double click here so that the formula expands across the entire data set. Okay. So once that is done, the task is very simple. We will select all the true instance. We'll deselect the true instances. Let the falses remain. So that will filter out the odd data set. We will delete the entire odd data set and then select the true data set that is remaining, which is the even data set. Okay, next, copy, and we shall paste it in the origin uh, worksheet. So the name of the sample was C3IA. Absorbance here. Now let us take any of the graphs as an example. So let us take the second one as an example and see what is the situation. So as you can see, the actual UV spectra lies between 240 approximately and 800 nanometer. So that is where we shall place our focus on. So yeah, 240. I guess this will be true for all the samples. So let me check it for all the samples. Okay, so that's approximately 240. And for the last sample too, let's see, the data set should be lying around 240 to 800. So let me just check. Okay. So anyways, taking 240 as median, let us see what is the situation here. We will go to 240. Okay, 240. We'll keep it as median and delete the rest of the data, which is not important in this particular case. Uh, this is I'm doing this because I am aware of the type of the compounds I'm dealing with, and I know where the UV visible spectral peaks will be there. In case of unknown compounds, this is not advisable. So, anyways, let us go for some smoothing of the data. So, you go to analysis, go to signal processing, open the dialog box. Here, you can select auto calculation or manual calculation. I'll go for manual calculation. There are various methods you can select. So I'll choose the Savitsky-Golay method. Uh, Regarding the number of points of window up to which a curve can be smoothened, it ranges from 0 to anywhere you can think of. So anyways, let us try smoothing the curve by 30 points. Okay. So the color in red here indicates the smoothened curve, and the curve in black indicates the original curve. Okay, so the smoothing is okay, I guess, with 30 points. So we'll stick to that. As far as the output of the smoothing function is concerned, you can set the output as a new column, or you can set the output as the input column itself. If we set the output as input column itself, then the smoothing will the smoothened data will appear in the original column. Okay, we will repeat the operation for the other. 2. So we just go for the last smoothening that we have done, and we'll go for smoothening of the. Seriously. Third data set as well. Okay, once the smoothing is done, then because of the different nature of cell samples, and I guess it was so. Anyways, since the samples are different, we'll go for normalization here. So we will normalize the column between 0 to 1, and we'll set the output as in a new column actually. So once the column is normalized, then level the appropriate columns, and we can plot the graph. So I'm selecting all the three curves, and we shall plot the overlaid curve. Okay. So this is our overlaid spectra. So let's say we are going from 240 to 800. Okay. So that's how we obtain an UV visible spectral plot from the raw data. Additionally, you can do certain tasks. As we can see in the dataset, two of the datasets are pretty clear with respect to the Q band for the porphyrinic compound that these are, and for the fourth compound, that is TCPP, the Q band is not that clear. So we can select that Q band. So hold down the control key, click on the magnifying glass with the plus sign, hold down the control key, and then select the dataset. So see the cubans are visible in a separate window right now. So what we shall do is we shall copy the spectral data from here, paste it in the original graph, and then delete it, and we shall adjust. So the data in inset represents the cuband of the compound TCPP. So the next step is exporting the curve. So before we export the curve, now this curve here, this red curve here, which belongs to E3IA, looks kind of odd. So what we shall do is we shall ungroup the data, and then click on hide data plot. So the data plot will be hidden. Anyways, you can increase the boldness of the line, so that is it is amply clear that it belongs to the TCPP curve. Now we'll go for the export function. Go to export graphs, open dialog, choose our file format as TIFF for that gives the best quality images. Use a long name. So in this particular case, I shall just write down the sample names and define the user path, and then click OK. So our UV visible curve is ready. So that's how you can plot successfully an UV visible spectrum from the raw spectral data. Thank you for watching. If you like my content, please do not forget to like, share, and subscribe.